Hello and welcome. My name is Xander. I will be your instructor through this tutorial. Now, this tutorial is actually part of a whole course which you can access the first stages for free here on YouTube. Now, in this tutorial, I might mention resources and other tutorials. Do check out the link in the video description, which will take you to the playlist, and also there will be a link to the resources so that you can access and follow along here on YouTube. Now, if you like this course, you found it useful, and you want to take that next step, you can find this course over at Udemy. All the links to the resources can be found in the video description. Now, don't forget, also subscribe to the channel for weekly promotions, discounts, and free course giveaways. A primary key is a unique identifier for each record in the database table. It ensures that no two rows have the same value in that column. Other than ensuring uniqueness throughout the table, the primary key also helps us retrieve data efficiently because we can select individual records in a table. It helps maintain data integrity and acts as a reference point for other relationships between other tables. Take this example here, the student table. The primary key is the student ID. Every single student ID record in this database table will have a unique student ID number. This follows the principles of a primary key field. You can see here the first record, student ID 1001. The second row, we have 1002. So two records, two individual or unique student IDs, and that would then continue throughout every single row in the table. So if I wanted to select a particular student, I can do that based upon the primary key. So I can return, for example, the first record based upon the student ID. We can uniquely identify all the data in that row, in that record, by the primary key. If we take a look at our ERD, we have already developed this, normalized the data to some degree. So we are working from this point. But if you take a look at every single table, you will find a primary key field. And we are using a surrogate primary key in that we have created this artificial field, which will allow us to store unique values, which will then allow us to uniquely identify individual rows in the individual tables. So if we take a look at the category table here, we have the primary key ID, and whenever we insert into the category table, this ID will be auto incremented by 1. So the first record we insert into the category table will be primary ID 1, and then 2, and then 3, and so on, as we keep adding new records in the category table. The basic rules for primary keys existing in our tables is that they must be unique. I think we have determined that. They cannot be null. So every row must have a value and they should remain unchanged. So typically primary keys, once they are set, they don't typically change. Now, typically in a database, we tend to use an auto incrementing number for the primary key. So if you take this example, the student ID column, on the left-hand side, you can see the first record is 1, the second record it is 2. So whenever we insert data into this table, we will find that we will have an auto-incrementing number being automatically created by the database and inserted into the primary key field. And to do that, we simply need to select one of these special PostgreSQL data types, which is going to perform that auto-incrementing task. So let's move back to the Postgres database documentation. I've selected numeric types from the data types section, like we introduced previously. Here we have a number of different numeric types, but if we take a look at the bottom here, we can see that we have a number of auto-incrementing data types. So we have auto-incrementing small serial, serial, and big serial. So you can see here that there's just simply a bigger range of numbers, and the storage size will increase based upon the numeric type that we use. So it could be a good idea to have a general idea of how much data is going to be stored in your table, because if you do have over 32 2000 records, then using a small serial, you would utilize all the available numbers. And that would cause problems in the long run. You would need to then change to a different data type to support a larger amount of numbers. So I think we're going to play it safe and use a serial numeric type in this case. It's going to support quite a lot of numbers, I think more than we will need. So we can see from the ERD diagram, there will be a primary key in each table, and they're all called ID. And we're going to be using an auto incrementing integer, in this case, the serial data type in PostgreSQL. If we take a look at the SQL needed for this, so we alter the table category, we're familiar with that. So we select the category we want to make the change. We then add a new constraint. We then create a name for that constraint, something relevant. So in this case, category for category table, and then primary key. And then we use the keywords primary key and then specify the name of the primary key for that table. Now, when a column is marked as primary key, PostgreSQL automatically applies not null constraint, the unique constraint, and it also automatically is indexed. So PostgreSQL creates an index on the primary key column for fast lookups. So let's go ahead and apply this. So let's alter the table category, and then let's go ahead and add a constraint. And it says column ID, a relation category, does not exist. Now you may have already worked out why that is, but here in PostgreSQL, a constraint is a rule. So we're trying to add a constraint, a rule or condition that's enforced on a column or set of columns. Now, of course, it doesn't exist. So we are going to need to, first of all, in this instance, create the actual column first. So let's go ahead and alter the table and go ahead and add the column. Notice that we are going to be using a serial data type, as we have already discussed. So the serial data type is auto incrementing, supports numbers from 1 to a very large number, and uses 4 bytes. Let's go ahead and make the column, and then we can go ahead and now alter the table to then go ahead and add the constraint. So we need to make sure the column name matches the ID, and then we can go ahead and add the constraint. So we've now created our first primary key. So let's take a look at the table. So this is going to be the category table. If we take a closer look, we can see here that we have this ID field. It is classed, or it has been defined here as an integer. We can see that it has been automatically assigned to not null, and we have this function here, if you like, which will apply the next available number in a sequence. So this is what's going to be triggering the auto incrementation of the number in that field as we add records. Now, a bit further down here, we can see we have a number of different constraints now. We have the category primary key constraint, which has created an index. We have the uniqueness on the name and the slug. So I'm going ahead and creating all of these different primary keys for each table. Just copy and pasting this in. If you prefer to type it out, then please do. All the source code is available at the end of this module. Right. So with that done, we can go ahead and maybe inspect some of the different tables. Let's go for products. It should be the same for each table, of course, because we are simply just adding the primary key field in a very similar way for all of our tables. So we have the ID primary key here in the products table, and we can see we have the index created. So in this tutorial, we were made aware of the auto incrementing field types that are available in Postgres database. We utilized this to create a primary key column, which in a database is a field which uniquely identifies each row in the table. Remember, a primary key must be unique, so no two rows can have the same value in the primary key columns, and primary keys must not allow null. So every row must have a value for the primary key column. Now here in PostgreSQL, when we define a primary key, it will automatically apply to that field, not null, and the unique constraint. So a primary key is essential for organized data, ensuring uniqueness and data integrity in our database.